All right, we're looking at 4.6, which is using congruent triangles. Okay, I think I've talked about this before. It is called cpctc. What does that stand for, guys? Anybody remember?
No,
cpctc. Corresponding parts of congruent triangles are congruent. But I am not going to make you write that for a proof. Corresponding parts of congruent triangles are congruent. So you can just write cpctc. So on your postulates and theorem sheet, you definitely need to have for the quiz tomorrow cpctc written down. Okay. Can somebody tell me when you would use cpctc?
When it is necessary.
That is correct, Nathaniel. You would use cpctc if you've already proven two triangles are congruent and you want to know if the angles are congruent or the sides are congruent. So you have to have the triangle already proven. Yes?
So cpctc means corresponding parts of congruent triangles.
Correct. Okay, so we're going to start with the given. The given here is that RT,
Are you recording?
yes, is congruent to AS. RS is congruent to AT. Okay? So we're going to write this in the given spot. Okay. This is given. Is there anything else on here that we know has to be congruent to each other? We know R to T is congruent. We know to AS. We know R to S is congruent, and to T, A to T. What else do we know, Nathaniel?
Angle AOT is congruent to angle ROS.
We don't know that.
Oh.
Yes, Eric?
Remember what he said. Angle SOR is congruent to angle TOA because of vertical angles.
Look at that picture. Everybody looking?
Yeah. Angle.
What overlaps?
The sides.
What side?
The hypotenuse. Right?
What side of the triangle overlaps? Eunice, you got a guess? You see, we're looking at this triangle right here, and we're looking at this triangle right here. What overlaps, guys? Side.
Okay.
Look, where does it have blue and red?
Side RT.
S to T. And we call them congruent because of what? Reflection.
Wow. I knew that.
You guys all knew that. I don't know. It was like a brain fart, like for the whole class. Okay. If you know that these are congruent to each other, all three of these, you know that. All right. So we know that these triangles are congruent by what? Who can tell me? Triangle RST.
Side.
Yes, is congruent to triangle AST by side. Okay, what are we trying to prove, though? We're not trying to prove the triangles are congruent. What are we trying to prove?
Angles.
Okay, so we're trying to prove that angle TSA is congruent to angle STR. So we've proven the triangles are congruent. How do we know the angles are congruent? By what?
Corresponding. Thing.
CPCTC.
Yeah, that thing.
Okay, now there's going to be some of you that are going to want to use CPTCC to prove that triangles are congruent. You can't do that. You have to already have congruent triangles, and you're proving the angles are congruent. Yes, Eunice?
Is CPCTC a theorem or a postulate?
I believe it's a theorem, and I believe it's in the back of your book on page whatever.
Yeah,
Yes.
Just so I can write it down, what does CPCTC mean?
Corresponding parts of congruent triangles are congruent.
Corresponding parts of
Congruent
congruent
triangles
triangles
are congruent. You don't put that in there because if it's not congruent, triangles are congruent. Okay, let's look at the next one. Okay. So, we're looking at this funky triangle here, this overlapping triangle. The first thing I'm going to do is I'm going to write down the given. SR is congruent to PQ. SR is congruent to TQ, and this is given. Okay, so looking at this triangle, we've got two sides that are congruent to each other. So we need an angle or a side. What do we have? We can have another side. Excuse me. RQ overlaps is congruent to RQ by reflexive. Yep. All right. So then we say that the triangles are congruent to each other. Triangle SRQ is congruent. Yep. To TQR by side, side, side. Therefore, QS is congruent to RT by what?
Yeah.
cpctc. Reflexive.
Wait, I thought
Statement, RQ is congruent to RQ.
Wait, I thought you said that the that thing
cpctc
can only be used to find the angles.
or sides, because it's corresponding parts. Hear that word parts? Of congruent triangles are congruent.
Doesn't it have to say triangle though?
Which triangle?
These triangles are congruent to each other.
Oh, yeah.
So now this is saying that the parts of the triangle are congruent. Yes.
Which triangles is it? The ones that are this?
Yeah. Yeah, they're overlapped in the bottom. Okay, let's look at the back. Okay, so I've been asked by a couple of people it would be easier for them if I separated the triangles so they could see which triangles I'm talking about. Is that true? Stop talking, please, while I'm... Okay, so we're looking at KML and KNL. Okay, and I know this because it's telling me that angle M is congruent to angle N, and that's given. So I know I'm talking about, I'm going to put in red the ones I'm talking about. Talking about this angle and this angle. And then I'm talking about angle OKL is congruent to angle OLK. This is also given. So we're talking about OLK, which would be this L right here, and OKL, which would be this angle right here.
The second one is OKL.
Uh-huh.
Wouldn't it be first one? Was it O? Or no?
Yes, but that won't help us.
Oh, okay.
What do they overlap at? What?
Oh, yeah.
Oh, they do, but that doesn't really help us.
Or KO.
KL, they overlap at KL.
So it'd be KL and KL is the triangle.
KL for reflexive. Good. Right? Then what do we got? We've got an angle, and a side. So the triangles are congruent.
What are the triangles called?
MKL and NLK. Therefore, MO is congruent to NO by cpctc.
Yes.
Can you repeat number 4 on the statement side?
On the statement side, triangle MKL is congruent to triangle NLK. All right, the next one's a little bit more difficult because we're going to deal with two triangles and then we're going to deal with two different triangles. So bear with me. Yes.
So when you're looking at where they, if you're saying you look at the line.
Or the angle, depending on what two triangles we're talking about. All right. So my given is angle 1 is congruent to angle 2, and angle 5 is congruent to angle 6. So let's mark those. Angle 1 is congruent to angle 2, and angle 5 is congruent to angle 6. Okay, before we start this proof, what other things, if we're talking about these two triangles then, what else do those two triangles have in common?
A to C.
Line AC, yep. Okay, so I can use that to prove that they're congruent. So that's what I'm going to start with. Angle 1 is congruent to angle 2. Angle 5 is congruent to angle 6 given. Then I'm going to go to the new part. I know AC is congruent to AC by reflexive. And then the triangles are congruent by what? We've got an angle.
Angle side.
Look at it again. Angle.
Angle side angle.
Right, because the side's in between them. Okay. Here's the hard part. I'm trying to prove that AC is perpendicular to BD. Well, BD is in the middle of my triangle. So I've got to look at this triangle as well. Okay, so the first thing I'm going to do is say, of that new triangle, I know that AB, oops, I just did a color. I know that AB is congruent to what? AD by what? C?
Yeah.
P, C, T, C. Okay, but that's not what I want to know.
Can you do BD or
So, but we're talking about the two triangles in red, so we can't usually use BD. We don't know that B to O is congruent to O to D.
AO for reflexive?
Well, let's think about this. We know that this angle, this side, and these sides are congruent to each other. So now we have side, angle, side. So we can prove triangle ABO, and I'm talking about the triangles in red now, are congruent to triangle ADO by side, angle, side.
Wait a minute.
Yes.
How'd you get ABC congruent to ABC, angle side angle?
Because I had, look at the green ones. I've got angle, side, angle. Now I'm looking at the red ones, and I've got side, angle,
Oh,
side.
okay.
So two different triangles, separate
Oh, I
triangles.
see the triangle.
Okay,
Is this ABC congruent to ADC or is it ABC?
this is
No, the first one.
ABC is congruent to ADC.
Okay.
Okay, so I know angle 3 is congruent to angle 4, correct?
Yeah.
By,
Right angle.
I've proved that these triangles are congruent to each other. And now I know 3 is congruent to 4 by cpctc, good.
What does number 5 say?
Side, angle, side.
No,
Oh, triangle ABO is congruent to triangle ADO. It is long.
is our homework going to be all proofs?
Okay. What does 3 and 4 make? 3 and 4, if I add them up and put them next to each other, it makes a
Linear pair?
linear pair. So I'm going to say angle 3 plus angle 4 equals 180, linear pair postulate. Okay. There are 2 more steps. I know there aren't enough room, or 3 more steps. So you're going to have to write these in at the bottom. Okay. So I'm going to substitute angle 4 plus angle 4 equals 180. This is substitution. Oh, maybe there's more than that many steps. Hold on. So 2 times angle 4 equals 180. We call that simplify. Now I'm going to divide by 2. Angle 4 equals 90. This is by division. Man, I didn't give you enough room at all. Sorry. It is not too long. Okay. So, what is angle 3? If angle 4 is 90, angle 3 has to be
90.
90. And we're going to call this, we're going to call it by definition. There's a better term to say it, but we don't have it. And if